CBT Nuggets JNCIA Series OSPF Deployment Lab. Well, now let's move on to the real protocol, okay? The one that we're most likely going to be using in our real-world implementation, even though let's don't, look down on RIP version 2. Remember, it's the only dynamic routing protocol that's supported by Windows Enterprise servers when they're performing as routers in an enterprise. So it's very common, you'll see in a Microsoft environment, for example, that their RAS servers are running RIP version 2, so it's very likely that you'll run into RIP version 2. So don't take it for granted, but OSPF is really where it's at, okay? So we'll do a quick little OSPF refresher, then we'll look at a single area OSPF configuration. We'll also do two route policies. One will be to advertise the default route to the service provider into the OSPF area 0, and then we'll also advertise an interface route into the OSPF area. A couple of great examples. Sound good? All right, let's dive in. Well, in the previous Nugget, you were given an assignment by Nugget Lab to go to Kiro Media and help them migrate their RIP version 2 network from Cisco into Juniper routers, which you did successfully. However, after a couple of months, they realized that they want to deploy something that's a little bit more modern, something a little bit more scalable, like, for example, the open shortest path first. So that is the method that we're going to take now, obviously going into Kiro Media as a representative of Nugget Lab, which is an IT consulting firm. And we're going to take our two routers and basically create an OSPF area 0, or as Juniper calls it, 0.0.0. Now before we dig into the topology here, which is what we're going to use for our deployment lab, and by the way, this is a little bit more elaborate than just a basic configuration of area 0. We've got a couple of links in here. I want to remind you of some of the characteristics of our link state interior gateway protocol, OSPF. As you remember from earlier, OSPF is a link state routing protocol. We use it within an autonomous system, for example, like Kiro Media. Link state protocols are going to converge faster. They'll support larger networks as we grow and become scalable. They're also a lot less susceptible to bad routing data, especially compared to their cousins, the distance vector protocols and RIP version 2, which, by the way, is one of the reasons why we're migrating or moving from RIP version 2 to OSPF. In addition, our OSPF routers are going to send out information or data about their network links along with the state of those links to the other routers in the autonomous system. This will be transmitted reliably to all the other routers using link state advertisements or LSAs. When the other routers get the information, they'll store it locally. Now, beyond just flooding LSAs to neighbors and discovering neighbors, a third major aspect of OSPF is to establish the link state database, or the LSDB. This topological database is really important because it stores the LSAs as a set of records. And this is important information for the shortest path first algorithm, or the Dijkstra algorithm. That's what we use to calculate the best path. And OSPF uses cost associated with networks or neighbors to calculate the best path. And this is done, by the way, to all the destinations in the autonomous system. And as we saw earlier, it does this by calculating a tree of shortest paths and picking the best candidate from that tree. Now, on the JNCIA, and when we go to Kiro Media here, all we're really concerned about is a single area OSPF deployment. However, areas can be used to accommodate for our hierarchical organization. We can also add new areas to facilitate a scalable implementation. Basically, an area is a logical group of routers like we see here, my J2320 and my J2350. Areas actually reduce the size of the link state database on the individual router. So if I had, let's say, 5, 6 or more routers, I could move routers out of area 0 into other areas. And from a practical standpoint, in an organization, I might have area 0 be the core, the collapsed core of my network, and area 1 could be, let's say, the data center or the server farm. If this were over a wide area network, area 0 might be my corporate head-end network, then the other areas could be branch offices, for example. So this can be done internally. It can also be done over a wide area network. Remember, each OSPF router is going to maintain a separate link state database for every area that it's connected to. Now, these routers are only in one area, area 0, but they could be area border routers and have a separate database for each area. Now, to make sure that we have proper connectivity and accurate information, OSPF is going to maintain a special area. And this is called the backbone area, and this is what I'm looking at right here. Area 0. Now, Juno's OSPF designates the backbone area as area 0.0.0.0. And this is very important, all the other areas, if we created new areas by the way, must connect themselves to the backbone for connectivity. In other words, all data traffic between OSPF areas would have to go through this area 0. So this is why this is the first step in our deployment here at Kiro Media. Once we have our backbone area configured and we have our duplicate links between these two backbone routers, we can then add a new area, for example, for the data center or the server farm or the demilitarized zone, depending upon our network topology and our needs. Okay, so this time we're going to be configuring our routers not in TerraTerm like I did in the previous RIP version 2 nugget, but we're going to use Poderosa this time. And so I'm going to use Telnet to these two different routers, and I'll pop between 2350 and 2320. You can see I'm on the 2350 now, which is over here, and the 2320, which is over here. And here's our topology. And I'm going to see here in a minute that I've gone in already and configured the interfaces. So if you're going to replicate this in your own environment, whether it's a virtual environment or whether you have your own routers, then you want to make sure that you can configure your interfaces accordingly. So I've already done this. And by the way, on both of these routers, you don't see gig E000. As we'll see, that is the actual management interface. So I'm using 000 unit 0 to access these devices from this management station, right? So we're not going to see that one. But gig E001 and 002 on both of these routers, so we'll stay on the 2350 over here. This is going to be on network 172.20.66, okay? So this will be .2. And this one down here will be 172.20.77.2. So I've configured gig E001 unit 0 and gig E002 unit 0 accordingly. I've also got loopback addresses configured on both of these routers, and you can see I've got this link up here to this network, which could be a wide variety of things, but that network up there, 172.18.2 link, and this is the .1 link that goes up to this network. Something else I've also done, I've copied one of the mechanisms from the previous nugget, and that is to nail up a route to, let's say, a simulated customer network or other partner network. So we've nailed up a route over here, 209.165.100/24, and I've nailed up a route over here, .200/24. Now obviously what we're going to see here is with each one of these routers, this has a nailed up route here and it has a connection on gig E03, just like this one does. However, we only want these two interfaces to be part of our OSPF area 0 or our backbone network, and we don't want this information at this point in time to be distributed into our backbone area. In other words, we don't want any adjacencies formed on interfaces that connect to the 003 interface or 18.1.2 or 18.2.2 over here. Now I'm going to go look at the 2350 here. You may want to go ahead and freeze this and maybe just kind of jot down what you see here, or I will make these diagrams available as PNG files up at CBT Nuggets. So make sure you understand this as we pop over to the 2350. So let's minimize this. Okay, I'm going to do a couple of show commands. First thing I'm going to do is I'm going to do show interfaces terse. And we should see here, this is obviously gig E00. This is my management interface. We can see here's 1.0, and that's the top link in the topology. 66.2. This is the bottom second link in the topology. 77.2. This is gig E003. This is the link up there to that cloud network on the top. And if I see more down here, I can see here's my loopback address I've configured at 192.168.2.1, and that's also in the topology. So really the three interfaces I'm going to have participating in area 0 are going to be gig E001 with this address, gig E002 at this address, and my loopback address, because actually my loopback address will be my router ID, okay, the identifier for OSPF. And that's pretty good there. Let's go look at the 2320 now. Okay, let's see what we got going on here. Here's gig E00, that's our management interface. All right, we've got gig E01, that's the top network, 66.1, okay, /30. Here's gig E002, that's 77.1. And then here is gig E03. This is the one that goes up to that network at the top, which will not be participating, by the way, in OSPF at this point in time. And then we can see there's my loopback address at 192.168.1.1. And I really don't want this address on there, so I'm going to go ahead and have to delete this loopback address on there, but I can do that in the background. Okay, so that looks pretty good. One other thing I want to look at here, let's go to Edit and then Edit Routing Options and do a Show command. And this is that static route that we nailed up, okay? And I want to have this as well. So on the 2320, this route is 209.165.100.0/24 with the next hop of discard. And I can go over here to the 2350 and we can see the same thing there. If I do Edit Routing Options and I can do a Show, and I should see the same thing. I've got a nailed up route there at 200.0 with the next hop of discard. Okay, so that's my basic fundamental configuration. I'm ready now to go and basically define OSPF area 0 and then include all of the internal interfaces that I want. And again, we're going to include that loopback address. Let's go ahead and go to the 2320 and do it there first. Now, I'm in the routing options hierarchy, so what I want to do is I want to go to the top and then get into Edit Protocols OSPF. Remember in the previous nugget, it was Edit Protocols RIP, so we're going to say I want to get to the top of the hierarchy, and I want to be in Edit Protocols OSPF. Beautiful. Let's go ahead and clear this out. Okay, so let's do a set command, and we can do a lot of things here. You can see we can set quite a bit of stuff at the protocol level in OSPF, right? And a lot of this stuff we're going to be learning about when we get to the JNCIS series. But I want to set, and we're going to do area 0. Now I'm just going to put a 0 in there, even though Junos is going to represent that in the configuration as 0.0.0.0, kind of a 32-bit IPv4 representation. All I got to do here is put 0 though. And then I'm going to put interface, and the first one of course was gig E001, not 0 because that's my management interface. Now I have to make sure I put in .0. That's the unit 0, okay, or like we say in Cisco, the sub interface. Don't forget to put that, because if you don't, then Junos will automatically make it unit 0, and that may not be what you want. So for example, if I were doing this on a VLAN interface or a .1Q interface, and it's, let's say, unit 100, you have to make sure you put that in there. Now something else I want to focus on here for a second is the fact that on this router, the 2320 and the 2350, I don't have any static routes other than the one that I nailed up, right? If I had any static routes, I got to be careful, because remember the static route is going to have a preference of 5, right? Well, OSPF routes have a less preferred preference of 10. So ultimately, if you had static routes and you wanted them to be OSPF, well, they may not be active in OSPF because OSPF has a higher preference, and those static routes would still be static or of type static with a preference of 5. So make sure that you, and you may have to do this as a troubleshooting measure. If you add these interfaces to OSPF and you go in later and you do, let's say, a show run route protocol OSPF, if the OSPF routes aren't active on those interfaces, then one of the troubleshooting things would be to go in and delete the static routes, okay? So you may have to go in and get rid of static routes. Okay, so there's gig E001, which is basically that top link between the two routers on 2320. Then I can just use the up arrow and say, let's go ahead and set interface or set area 0 interface 002.0. Okay, so that's the bottom link between the two routers. And then let's go ahead and set area 0 for interface loopback 0.0. Get that loopback address in there as well. And now we can do the show command, and we can see there, like I told you, the way that this is done in OSPF is it's going to be area 0.0.0.0. Our container there shows interface gigi 001.0, 2.0, and loopback.0. Don't forget this command, okay? Show protocols OSPF. Now I want to go ahead and do a commit here, and then we'll go over to the 2350 and we'll do the same thing. Okay, so let's go ahead and get to the top. This is edit routing options, so I want to go to the top and get to edit protocols OSPF, correct? And we're going to set area 0 interface gig E001.0 and then 2.0 and then interface loopback 0.0 and do a show command. They're in there, and commit. Let's go back over to the 2320 and go to the top. Okay, let's go ahead and verify that we have an OSPF neighbor adjacency. And we're going to do this. The command is actually show OSPF neighbor, but we're in edit mode, so we'll do run and then show OSPF neighbor, or just NEI, and hit enter. Okay, so I can see that my neighbors, so I'm over on the 2320, right? So my first neighbor is at 66.2 on interface 1.0, and if you do this right away, the state may be something like init. By the way, if you see init and it stays in the init state, then you've got a problem, okay? And let me tell you some of the problems I've had in the past when I've been working through my equipment is a couple of times, for example, on my 2320, I reverted back to the rescue configuration, right? I went in and did a rollback to the rescue. Well, my initial rescue configuration actually was before I converted this 2320 from secure context to router context. You with me? So what happened is I went in, I did rollback rescue, but the rescue configuration was actually this router in secure context. So when I went back into secure context, I obviously had some firewall settings that are part of that secure configuration, and so that was problematic. So I had to make sure that I changed my 2320 from the secure context to the router context, made my configuration, then created my rescue configuration. So that's something I've run into from time to time when I've tried to just kind of start over and revert back to the rescue config. So if that happens, keep that in mind. So what I'm looking for, though, is this OSPF state as full. So I can see these are my two links. And let's go ahead and bring up our diagram again. Right about here. I'm on the 2320. Here's my two links, right? 001, there it is, interface 01. 002, there it is. You can see the neighbors at 66.2 right here, 77.2 right here. We're in the full state. What's the ID? What is the ID of the neighbor? The router ID is the loopback address, right? 192.168.2.1, and these are some other timers right here. We'll learn about these values when we get to the JNCIS series. Okay, so let's go ahead and go to the 2350 and take a look at that one. We'll clear the screen, go to the top here, and we'll do the run show OSPF neighbor and look at it from this particular standpoint, right? And we have our diagram up here. We can see that the address is the opposite, 66.1, so we're in the 2350, so it's 66.1, 77.1, on the interface 1.0 and 2.0, we're in the full state. That's good. You don't want to see init or two-way, anything like that, for any period of time. After a few seconds, this should go to full. And then the ID Notice the ID is the other loopback address, the 2320 1.1. And by the way, this is why we really use these loopback addresses, is because these are our router IDs, and this is a very common thing to do in OSPF. And you can see some other timers there. So that's one type of verification we can do, okay? The show OSPF neighbor command, or if you're at the edit mode, run show OSPF neighbor. Let's go up here to operational mode. On the 2350, let's do a show route protocol and then OSPF. We can see we have a couple of routes here. We have a route to 192.168.1.1/32. This is the loopback address of my 2320. We can see that it's the OSPF protocol. Here is our route preference, which is 10. That's not as good as static, which is 5. Definitely not as good as direct, which is 1, but it's a heck of a lot better than RIP version 2, which we saw was 100, okay? And we can also see a couple of different routes over to that other router. We can see our preferred route, obviously, is along the 66.1 GIGI001 interface path. We can also see the multicast that we're using here for OSPF. Remember, we used 224.0.0.9 in RIP version 2. We're using 224.0.0.5 here in OSPF. Let's go ahead and ping 192.168.1.1 rapid while we're at it. Excellent. We have reachability to 2320, and we'll come over here and we'll do the same thing. Let's get to the top and run ping 192.168.2.1 rapid. There we go. Excellent. Now, while I'm over here on the 2320 in operational mode, let me just do a full-blown show route command so we can see our entire route topology here. So we've got 10 routes, 10 are active, and we can see here, obviously, what we're looking for are some of these primary ones here. We've got these, obviously, these are direct and local, but as we go down here, here's a route to 192.168.2.1, which is the 2350 router. The asterisk means it's an active route. Actually, it's, and the preferred route that we're going to be using is going to be to 66.2 on interface GIGI001 unit 0. Here's our static route, by the way, which is the one that we have nailed up, 209.165.100.0 with the next hop of discard. And of course, here's also our multicast for OSPF, 224.0.0.5/32, and again, OSPF with a preference of 10. And we can see our preferences here all along the way. Excellent. Okay, now that we have our two OSPF peers in our single area OSPF implementation, we want to go ahead and use our routing policy, and we want to advertise routes into OSPF. So we'll first generate a routing policy to advertise routes into OSPF, then we'll apply a routing policy as an export policy. And then of course we'll use those operational mode commands, verify that our policy is working properly. Now realize there is no single way to do a lot of things. Often in routing, whether it's Juniper or others, you can accomplish the same goal by using several different methods. So this is not the only single way to do this. But one thing we might want to do if we look at this diagram is, what if we have this particular route here, which is going to be the default route, okay? So this is the default route out to the internet. It's possible that we might want to go ahead and advertise this default route. We'll have to, of course, make it the default route first, but once we do that, we want to advertise that into OSPF, into our OSPF area 0. That way all of our participating routers in this backbone will know that the default route out to the internet is on this particular link to the service provider. And of course, in a more elaborate environment, you would have multiple links to service providers, or preferably you would have two service providers for high availability and redundancy. You could have multiple paths out of your corporate enterprise network. Let's take a look at our configuration here. Okay, so since our routing policy is basically going to advertise this default route up to 172.18.1.1 into this OSPF area, Let's first of all make sure we have connectivity from this J2320 up to this service provider router. So I'll run a ping to 172.18.1.1. We'll make it rapid just to make sure. There we go. Okay, so that's good. We've got connectivity there. Now let's go ahead and set our static route. So we're going to edit routing options. We want to set the static route 00, and the next hop is going to be 172.18.1.1, and we'll commit that. Let's do a show. Okay, so we've got this. Of course, this is our nailed up route of that other network, and here's our default route 0.0.0.0, next hop 172.18.1.1. Excellent. Well, now we want to go ahead and create our policy. So I'm going to go to the top and then edit policy options. Not routing options, but policy options. So we'll say edit, and the policy statement, let's call this def_RT for default route. Okay, so we're going to go ahead and set the first term, and I could say set term 1. And in my RIP version 2 routing policy, I called my terms term 1, term 2, and you could do that, but typically when you get into the real world, when you get to Nugget Lab or you get over to Kiro Media, you probably want to start naming your terms so they're more intuitive, right? Even though it's the first term and the second term, they have intuitive names. So I might call this one, let's say, default static route. Okay, def stat route. That's the first term. And I want to go ahead and say if it's from protocol static. That's my first term. And then we're going to say in def stat RT. Static route's not enough. We also want to say is it from, and we'll do a route filter. And of course the static route is 00 or 0/0, and it has to be an exact match. Oh, and I didn't spell that correctly, so let's make sure we exact. Nice little syntax error there. Thank you. And of course we want to say set term from, then we'll accept it. Set term default static route, then accept. A lot of syntax errors, but sorry about that. Do a show command. We can see the term is default static route from protocol static route filter default route exact, then accept. Okay, that's good. Well, we want to go ahead and set this, implement this export policy in OSPF. So we need to get to a different hierarchy. We're going to say we'll go to the top and then we'll get to edit protocols OSPF, and we want to set the export policy for OSPF, and what do we call this? DEF_RT, no syntax errors hopefully, and then we'll commit that. And let's do a run show route 00 exact, and we can see our static route going to 1.1 via GigE003. Okay, very cool. Let's go see what's happening over there on the 2350. Okay, on the 2350 now, hopefully we've had this information injected to or distributed into the OSPF area 0 from the 2320. So we'll do a show route protocol and OSPF, and there it is. There's our default route, okay, 0.0.0/0. It's from the OSPF protocol, but look at the route preference, okay, 150, okay, not 10, but 150. What's going on there? Well, that's an OSPF AS, or Autonomous System External route. This is a route from OSPF that's been redistributed into OSPF. Awesome. And we can see to get to this particular default route, we need to go through this preferred route on GigE001 to 172.20.66.1. Now, obviously, when you get farther along, you'll start to look at things like tagging your routes and doing other routing policy like that. That's an example of something we can do with route policy. But so now we have on the 2350, we have the default route that's been distributed into this area. Here's our route, of course, to the loopback address of the 2320 router, and of course, here's our multicast OSPF at 224.0.0.5. Excellent. Okay, let's try this. Remember over here on this router on interface gig E000, this goes to my management VLAN, which we know is 192.168.3.0/24. Let's see if we can actually advertise that particular route into OSPF area 000. Let's give it a try. Let's get into Edit Policy Options area. And let's say this is going to be a policy statement. Let's call this ENT_RT, interface routes. Okay, so this is a route to a particular interface on this. So we're going to set the term, and I'll just keep it term 1 from, and we'll do a route filter 192.168.3.0/24, and we'll say exact, and then we'll say set term 1, then accept. And let's get up to the top and then edit protocol OSPF, not ISPF, OSPF. And then here we want to set the export policy to interface route. So we're routing to other connected interfaces, and we'll commit that, and we'll do a show. And we see we have a couple of export policies here now, default route and interface route. Let's see if we've had any luck getting that over into the 2350 yet. Come up here, and we'll do a show route protocol OSPF. All right, there it is. There's our 192.168.3.0 network. That's the management VLAN that I'm operating on right now. So we're advertising that management VLAN into the OSPF domain. Again, we can see it's external 150. That's the preference. To get to this network, we're going to actually, in this case, go on gigabit 002.0 to 172.20.77.1. It's interesting. So we're choosing this interface and this destination IP address to get to the other router. We're choosing 66.1 and gig E001 to get to the default gateway, but we're choosing that other link, okay, to 77.1 on gig E002 to get to this management VLAN. Okay, so let's take a look. We're choosing this link right here to get to this management VLAN, but we're choosing this link right here to get to the router itself, the loopback address, and to get to the default gateway out here to the service provider. And again, we can use policy, and we could even influence which link is being used. We could also go even deeper and configure another link on this particular router going up to the same service provider or a different service provider, and we can route traffic, either external information or typically other routers inside of our OSPF area, and rig the game to move traffic and forward traffic through these particular routers. Now, this is the only router right here that connects to the service provider, but as you go farther along in your knowledge, farther along into the JNCIS, we're going to see all different types of scenarios that we can implement at Nugget Lab and Kiro Media. Excellent. Okay, in OSPF Deployment Lab, we looked at an OSPF refresher, kind of just, hit the high points of this link state algorithm. Looked at a single area OSPF configuration with 2 routers and a backbone, a routing policy for a default route, and a routing policy for an interface going to our management VLAN. Now, even though these are the 2 official deployment labs we looked at, RIP version 1 and OSPF, we're not done with our labbing. Okay, we're not done labbing it up. We have a couple of things coming up. We're going to be looking at firewall filters, okay, coming up after this. Firewall filters. Then we'll be looking at class of service. Okay, so we're going to still be actually doing some configuration scenarios in the next couple of nuggets. So I hope this CBT nugget has been informative for you. I want to thank you for viewing.